This is the first part of 3 which show how to use SolidWorks Motion to analyze a suspension system from a Formula SAE car. This part will point out how to eliminate redundancies in your model, which will be very helpful and necessary when using SolidWorks Motion. First thing is first, what are redundancies? Redundancies are when multiple mates remove the same degree of freedom from a single joint. For instance, if you are creating a pin joint, you would most likely use a concentric mate between the two cylindrical faces and a coincident mate between two of the flat faces. In this case, the concentric mate removes 4 out of the 6 degrees of freedom. These are the rotation about the x-axis, the z-axis, as well as the translation in the x and z direction. The coincident mate with the two surfaces removes the translation in the y direction, as well as the rotation about the x-axis and the z-axis. Those two mates remove 7 degrees of freedom out of the max possible of 6. The pin is still able to rotate about the y-axis, which means it still has 1 degree of freedom. It is because both of the mates remove rotation about the x-axis and the z-axis. Here lies the two redundancies. To verify this, you can create a new motion study and add gravity into it. When you run the study, it will say that there are 2 redundancies next to the mates folder. By right-clicking that folder and selecting Degrees of Freedom, it will list that there are redundancies in the mates. In this case, it says that there are redundancies in the coincident mate about the x-axis and y-axis. The reason it is not the z-axis is because these are in terms of a local coordinate system based off the joint. Typically, the z-axis will be on the joint axis of the mate. This makes sense because the local z-axis would be the one that the cylinder is still free to rotate about. Therefore, the 2 redundancies are the rotation about the x-axis and y-axis in the local coordinate system, which correspond to the x-axis and z-axis in the global coordinate system. There are a variety of different ways to fix this. The simplest way would be to add a hinge mate between the 2 parts. This mate will remove 5 degrees of freedom, and there will be no redundancies. When eliminating redundancies, it is sometimes helpful to use points and axes to mate parts because it gives you more control on which degrees of freedom that you remove. The next part of this video will show how to set up a motion study using SolidWorks Motion on a suspension system from a Formula SAE car.